With our 1.2 notes. That's really thin, isn't it? And that title was Rational Exponents.
Rational exponents and properties of exponents.
Mm-hmm. Okay, so just in review, when I have what variable did I use the other day? A. So the eighth root, that's weird, of x to the m, it is x to the power over the root, right? So it's the base. The root is here. Base. Power. So it's the base, the power over the root. Now, when I just have a radical with nothing else, what is the imaginary number right here? 2. Not 1, 2. We don't do a first root because that's every number. Nope, right there. There's an imaginary 2. So that's something you need to remember because on your IXL, I helped a couple of people with those. So today our learning goal is not to switch back and forth because we're going to have to use switching back and forth to solve things in some cases. So we have, what is the solution to, just do this. We're just going to do a bunch of examples. I have 3 to the x over 2 times 3 to the x over 3 equals 9. So remember we talked about our exponent rules the other day? So when I multiply, what do I do to my exponents?
Combine.
I combine them how? Your choices were addition, subtraction, or multiplication?
Addition.
Addition, because when we do the product, we add. So we have, we're going to have 3 to the x over 2 plus x over 3 equals 9.
Is that x over 2?
X over 2. In order to add fractions, I have to get what? Nope. Common denominators. So my denominators are 2 and 3, so what would the common denominator be? 6. So, side note, I have x over 2 plus x over 3. So if I'm going to make it 6, I got to multiply this one by 3 and this one by 2. So that gives me 3x over 6 plus 2x over 6. So 3x plus 2x is 5x over 6. So now I have 3 to the 5x over 6 equals 9. Hopefully you guys all wrote in erase pencil, because I messed up. This is 3 to the 9th. Okay, so we have this amazing property that says once I have one exponent on the left, or one base on the left and one base on the right, and those bases are the same, the exponents are the same. So is 3, does 3 equal 3? Yes? So that means that 5x over 6 equals 9. So to get from here to here, we use when the exponents, when the bases are equal, the exponents are equal. So this is a really, don't you think that might come in handy a lot? Think so? Yeah. So now I have 5x over 6 equals 9. Is that a basic algebra problem I can solve? Yeah. How do I get rid of the 6 in the denominator? That means I'm dividing by 6. What's opposite of division? So I multiply both sides by 6. So over here the 6 is reduced. So I have 5x equals, and 9 times 6 is 54. And then that's 5x, so I would divide by 5. So x equals 54 over 5. And you're not going to get whole answers every time. Not going to happen. Okay? Let's do another one. So I have 2. I love how this book is so small. 2 to the x over 4 times 2 to the x over 6 equals 2. So what am I going to have to do with my exponents? Add them. Okay. So it's going to be 2 to the x over 4 plus x over 6 equals 2. What's the exponent on this 2 that's on the right-hand side? 1. So we just need to remember there's a 1 there, right? Okay, so what's our common denominator with 4 and 6?
24.
How it's smaller. 24 works, but there's a 12. Wouldn't 12 be easier? Okay, so what do I need to multiply the 4 by? 3. And what do I need to multiply the 6 by? 2. So I get 2, so it'd be 3x over 12 plus 2x over 12. Just getting common denominators like I would any other day, right? So I got 3x and 2x, so I have What's 3x plus 2x?
5x.
5x. So I have 2 to the 5x over 12 equals 2 to the first. So I'm down to one base on both sides. Once I'm down to one base, are the bases equal? So what does that make? The bases are equal, then what? The exponents are equal. So I have 5x over 12 equals 1. And I'm going to clear this 12 by multiplying by 12 on both sides. So that reduces here. So 5x equals 12. So what does x equal? 12 over 5. Okay, so I had to just step through the problem, and that's what you're going to need to do so it doesn't get overwhelming, okay? Let's do another one. So I have 27 to the x minus 4 equals 3 to the 2x minus 6. No fractions this time,
We divide.
but our bases aren't the same, are they? Nope, we can't divide yet because those aren't just normal, those are exponents. So what we need to do is get the same bases. So this is where knowing our powers really comes in to help. Is 27 a power of 3?
Yes.
It is. It's 3 to the what?
No, or no. 3.
3. 3 to the third. Okay, 27 is 3 to the third. Because 3 times 3 is 9 times 3 is 27. So I'm going to change this 27 into 3 to the third, but it's still to the x minus 4, isn't it? Equals 3 to the 2x minus 6. So do we have the same bases on both sides? Yeah, so we got that part done. Now I have a power to a power. What was the rule I gave you the other day when you had a power to a power? What were you supposed to do with your exponents?
Multiply.
Multiply them. So I have 3 times x minus 4, so I have to distribute that 3, don't I?
3x.
So I have to do this. So I have 3 to the 3x minus 12. And 3 to the 2x minus 6. Okay, so do I have the same bases? Yep. Am I down to one base and one exponent on both sides?
Yeah.
Yes. So now the bases are equal. What's equal? The bases are equal, then the and the bases are equal, the what? Exponents are equal. So are we ready to set the exponents equal to each other? Yes. So 3x minus 12 equals what?
9.
No.
3
Equals what?
equals
2x minus 6. The exponents, you just set them equal. And now I solve it just like any other algebra problem.
Distribute.
No, we're solving, so
Minus the 2 to the
minus the 2 to the 3 and add the 12 to the 6. And I put it above because I'm gonna have to subtract them, right? So 3 minus 2 is 1. Equals, and 12 minus 6 is 6. So x equals 6. Okay, there's a rule that wasn't given to you the other day when we did addition, subtraction, and distributing, right? Multiplication. It's one that you need to be reminded of. So if I have a to the negative x, if I have a negative exponent, that reciprocates it, so it's 1 over a to the x. At the same time, if I have 1 over a to the x, it equals a to the negative x. So if I can put it into the denominator with the negative, I also can take it out of the denominator. Does that make sense? I can use that rule both ways. Got it?
Okay.
So this is an important rule. You don't want to forget it. When you end answers, you never have negative exponents. So what happens is like we have 1 over x to the negative third. So I can't have a negative exponent, right? So it's in the denominator. I have to bring it to the numerator. So it's just x to the third. Or you would have, you get the answer of x to the negative 10th. Well, you can't have a negative exponent when you're done, so it's 1 over x to the 10th. That's how that rule is used. Okay? That's the very basic how that rule is used. And so now we're going to use that rule to solve equations and see, make it help us get bases that are the same. Because if the bases are same, the exponents are same. And then we can do a lot with it, right? Am I good to move it up? Eddie, am I good?
Yeah.
Okay. So I've got 1 over 125 to the negative x over 2 equals 1 over 25 to the negative x over 3 minus 2. Okay, so first we need to deal with 125 and 25. And we're looking for powers, right? So 25, you know, is what? 25 is a perfect square. What times what's 25? 5, right? 25 is 5 squared. So what do you think 125 is? 5 what?
5.
5 quarters, right? 5 quarters is $1.25.
Yeah.
Well, quarters were 2 5s, yes? So it's 5 cubed. But they're in the denominator. Do I want them in the denominator? Nope. So how can I bring it out of the denominator? I can make the exponent what? From here to here, I can make the exponent negative, can't I?
Yeah.
Okay. So this 125, I'm going to make 5 to the negative third. And why did I make it negative? Because I brought it out of the denominator, yes? Okay, equals, so what are we going to do to the 25? 5 to the what? First of all, getting it out of the denominator, we have to make the exponent negative. And 25 is 5 what? Squared. Okay. And we still have it to the negative x over 3 minus 2. Okay. Do I have same bases now? Yes. I got that part taken care of. So every problem so far, we've gotten the same base as the first thing, right? Then we got to deal with our, so a power to a power, I multiply them, yes? And a negative times a negative would be a positive. And then it's numerator times numerator, denominator times denominator, correct? And reduce if I can, but none of that reduces, right? So it's going to be 5 to the not negative anymore, but positive 3x over 2. Does everyone get how I get 3x over 2?
Yeah. Yes.
Okay. Now on the other side, I have to distribute, don't I? So I'm going to have 5. And negative 2 times negative x over 3 is going to be 2x over 3. And negative 2 times negative 2 is positive 4. Okay, so are the bases equal? And we're down to one base, so I can set the exponents equal to each other, right? It's bad enough I have fractions, but then to have fractions in exponents is too much, right? So we're going to have 3x over 2 equals 2x over 3 plus 4. Now, so far, I've gotten common denominators, right? Yeah? And you guys have dealt with that okay. But I know some of you are going, I don't even know, I couldn't do that on my own, correct? So, this is what I tell everybody in my classes. If you don't like fractions, you need to learn how to get rid of fractions. Make sense? If you don't like the fraction, you need to learn to get rid of the fraction and do the work. Now, the fraction may come back in the end, but I won't have to work with the fraction, okay? So it's still finding common denominators, but for some reason our brains like it better. So what do I have in my denominators? What are the two numbers? 3 and 2. So what is the one number, 3 and 2, the smallest number that 3 and 2 both go into? 6. So I'm going to multiply everything out here by 6. And you notice I went the both sides of the equation. Everything is getting multiplied by 6. Got it? Everyone following so far? And this is 6 over 1, and this is 6 over 1, and then this is just 6. So 4 times 6 is 24. That's the easy one, right? No fraction involved. Now, does 2 go into 6? Yes. So 2 goes into 2 once. So now it's already a whole number, isn't it? And 2 goes into 6 how many times? 3. So I have 3 times 3x, which is what? What's 3 times 3? 9. So it's 9x. Look at that. Fraction went away for a little bit. Okay, so I'm going to do it the same way. 3, does 3 go into 6? Yeah. It better, because that's why we chose it, right? So 3 goes into 3 once. 3 goes into 3 twice. So 2 times 2x is what?
6x.
2 times 2x?
Or 2 times 4x.
to 4x. Do I have any fractions there anymore? No. You did the same work, but in your brain, it's going to seem easier because you're not looking at the fractions anymore. So now what?
Now we subtract the 4.
Subtract the 4x.
5x.
So I get 5x equals 24. And then divide by 5. So x equals 24 over 5. Did we still get a fraction in the end? Did we trick ourselves and make it look better? A bit. And then they turned it into a decimal. Don't turn it into a decimal. Why waste your time, right? Yeah. I think we need to do another one of those, don't you? Yeah. Yep, yep. Okay, we got 256. To the x plus 2. Equals 4 to the 3x plus 9. Well, we're hoping I can get 256 to a power of 4, correct? So we're hoping, just because 4 is the smaller base, right? Well, 4 times 4 is what? 16? Times 4 is 64. Do I gotta keep going? Times 4, 16. Oh, look at that. 256. So how many 4s do I have? 1, 2, 3, 4? So 256 is 4 to the 4th. So 4 to the 4th equals x plus 2 equals 4 to the 3x plus 9. Now, could I actually go down to a power of 2? Is 4 a power of 2?
Yeah.
Yeah. Would this make this harder? Yeah. It wouldn't be 4 to the 8th. I mean, it wouldn't be 4 to the 4th. It'd be 2 to the 8th. And that would take a long time to get to, wouldn't it? Okay, so always try that smaller number and see if that works. Okay? So do I have one of the same bases on both sides? Yep. So how am I going to combine my exponents on the left? Distribute. So I'm going to have 4 to the 4x plus 8 and 4 to the 3x plus 9. So now that I've consolidated my exponents, the bases are equal. What's equal? The exponents. So Blake, tell me what I put down. Just bring them down. What are they? Read them. Yeah.
4x plus 8 and 3x plus 9.
That's it. So solve it. I think this is the easiest one we had so far, isn't it? X equals 1?
Yeah.
think we need to do another one, don't you? Another fraction one, maybe? Would that be good? Okay, so 1/8 to the x over 2 minus 1 equals 1/4 to the x over 3. So to get the 8 and the 4 out of the denominator, what am I going to do to the exponent? Make it what? Negative. So I'm going to make my exponent negative no matter what it is, right? Okay, so remember I said see if you can make the smallest number be a power to get to the bigger number, right? Is 8 a power of 4? No, because 4 times 4 is 16, correct? So 8 isn't a power of 4. So what's my next option? What's smaller? 2. Because 4 is 2 what? What power of 2, right? 2 squared. And 8 is 2 to the what? The third. Correct? Okay. So, and Addie said we just need to make the exponents negative, right? So I'm going to have 2 to the negative third to the x over 2 minus 1 and 2 to the negative 2 to the x over 3. Now, I'm going to tell you guys, there's some people that leave those, and they would have it 1 over 2 to the third equals 1 over 2 to the fourth, and they would leave it that way, and they would be okay with that. I'm not okay with that, because there's other steps you have to do that make it harder. So let's just make our exponents negative and get them out of the denominator. Sound good? We all know how you guys freak out when we have fractions anyway, correct? Okay, so what do I need to do with my exponents? Because I can't make them equal to each other yet. What do I have to do to them first? I have to combine them, correct? So am I going to add, subtract, or multiply those exponents? It's a power to a power, so I'm going to
Divide
times. So I'm going to distribute that negative 3 across and then multiply by negative 2. So I'm going to have 2 to the negative 3x over 2 plus 3, because a negative times a negative, equals 2 to the negative 2x over 3. So am I ready to go? Bases are equal, so exponents are equal. So 3x over 2 plus 3 equals negative 2x over 3. Anybody remember what I want to do now? I could get common denominators, but do I have it to show you a method to get rid of those denominators altogether? What's the smallest number that 2 and 3 both go into?
1,
Go into, multiply 2.
3.
2 and 3.
6.
6.
Oh,
Not goes into them, they go into.
oh.
So I'm going to multiply everything by what? 6.
Yep.
So 3 times 6 is the easy one, right? 18? Because it's a whole number.
Yep.
Remember, this is 6 over 1. So does 2 go into 6? How many times?
3.
3. So 3 times negative 3x is,
9.
how about negative 9x?
Yeah.
Okay. And then on the right-hand side, 3 goes into 6. How many times? 2. And then negative 2x times 2 gives you
Wait, what?
negative 2x times 2.
Negative 4.
Negative 4x. And now do I just have a basic algebra problem that I've done a million times?
Yes.
So add 9, right? So 18 equals 5x. So divide by 5. So x equals 18 over 5. Okay, so tomorrow we will have, I had IXLs tomorrow, but I don't know if we're ready for IXLs. What do you think?
Probably not.